folks. So this is lab 12. 12, so problems 1 and 2. Because what we do is we do problem 1 and then we convert it to problem 2. With problem 2, we create functions out of the things that we have to do. Now, what we're going to do in this is we're going to use math. We have to use math library. So we have to use the math library. So we might as well just import that. It's the only way we're ever going to be able to use it. So why do we need the math library? Because what we're doing is we're asking for the radius of a circle, and then we are calculating the perimeter and the area. So we got formulas for that. We got this formula for the perimeter, and we've got this formula for the area. Now, both of those formulas use pi, and they want us to get the pi from the math library. So yeah, okay, so we got one input, which is the radius. So we can just say, okay, radius takes a value of, and it is a float value. So we're going to ask the user to enter we're going to enter a number, and that's going to be the radius. So that's this thing here, enter the radius of a circle. And then we're going to do the conversions. So the area, so which one is first? The first one is the perimeter, and the next one is the area. I suppose we can do the calculation and then the print. So the perimeter is going to be equal to, we take the, well, we can have our formula right here, right? Perimeter is 2 pi r, 2 times pi times r. So that's okay. So it's equal to 2 times pi. Pi, we get pi from the library, just like that, times r is the radius. So there's our perimeter. The other thing that we need to calculate, well, let's just print it now. So the perimeter is this, copy that. So the perimeter of the circle is, and it is this value that we've just calculated. Now, if you wanted to save yourself time and typing, you wouldn't have to actually, in the way this program is written, you wouldn't actually have to have a variable called perimeter. You could just where I put the string here, you could copy this and put that inside the string, the formula inside the string, and you could just print out the result that way. You can do that, or you can call a function from inside of a print statement. People do that all the time, but that would save typing, because we wouldn't need this whole line of code, but you don't need to. Now, the other thing that we're going to calculate is the area, and so that's going to be equal to pi r squared, right? Pi r squared. So r squared, I could just do r times r. That would be an easy way of doing it, but since we're doing math libraries, maybe we can do it with the math library function, which is power. And so we could say, okay, so the area is equal to pi r squared, right? So pi is math.pi, and r is, so we're going to put a times in there, and r is, I'm going to use the math power function. And how that works is you have an x and a y. It's trying to tell me to do the x and the y. The x is going to be the value that is the base, and the y is going to be the power that it's raised to. And so the thing that's the base is the radius, and it's raised to the power of 2. So this is another way of saying pi. I don't even have a symbol for pi, do I? Do you suppose I got a symbol for pi? No. Pi r squared. Anyways, that's what it is. pi times r times squared times r squared. That's what that is. Okay, so now we can just print that out. That one is here. The area of the circle is the area of the circle is area. Okay, we can test that out now. If I try and run it, it'll make me save anyways. So when I save it, I'll call it lab 12 problem 1. I got it uppercase land 12. Oh, that's bad. Lab 12 problem 1. Okay, so in our run on this, what we got is .2. So that's our input, and it should give these numbers 38.9578. Yeah, okay, so we got the exact same numbers. So we know our program works kind of like that. Now, exercise 2, we're going to take the same program and we're going to edit it so that what? Let's go back and look at what exactly does it do. We're going to add 2 functions, and they're fairly trivial functions, circle perimeter and circle area. Call these 2 functions. So what the 2 functions that we're going to have one. Oh, don't use caps lock. Circle perimeter. Going to have that function. And that's going to take in a parameter r, and it's going to basically use this function. I'm going to be lazy. I'm just going to copy this. This is what the function is going to do. Okay. So you need to have a colon at the end. Then there's your function. Now, what it has to do, it has to return that value. And okay, so this is radius. I'm not using radius here. I purposely didn't use radius because radius is a global variable, and I don't want to use a global variable. I want to have a local variable. And likewise, perimeter, let's just call this P. So let's make it nice and short. P and R, and I'm going to return P. P is going to be the perimeter. And so here, where I had that, I can actually have that formula. I can say perimeter. Instead of doing the formula, I can just say perimeter takes the value of this function. When you pass the radius to it. Now, I hope you notice the difference between here. These are local variables. P and R are local variables. They only exist in this function. And I have global variables that kind of relate to them. I've got a global variable called perimeter. What happens in this statement here? This is the 2-step process in a function, right? The 2-step process. First, we define the function. Here, we're defining the function. Then here, this is the main program that's starting here, right? In the main program, we call the function, and we call the function by its name, and we pass any parameter to it. This is input to the function, and that's a global variable called radius. But it comes into the function as a local variable so that we don't mess up our global variables. Okay, and then there's a return value, which is also a local variable. And then I set that to a global variable so I can use it for my print. Okay, and so we can do the same thing for the other function, which is circle area. I'm purposely doing this copy and paste because that way I won't get spelling errors, right? That's a big problem that a lot of us have, including myself from time to time. We get spelling errors because we're looking at it. We think we're spelling the same thing, but we're not. I'm going to use the same kind of local variable as we did last time. So that's going to be R. I'm going to take this formula from here. And that's going to be my formula that's happening inside there. Now, the thing is, I'm not going to use this radius because radius is a local variable. Sorry, a global variable. I only want to use my local variables. And likewise with area, make a nice local variable there, and then return A. And so then I can have a call here where I'm going to get the area. And how I'm going to get the area is by calling this function. And I have to use the global variable. So in the main, all the variables I'm using are global variables. I hope you notice that. See the pattern? These are global variables: radius, perimeter, area. In the actual functions themselves, I'm using local variables, which are never shown in the main. Okay, so this is actually problem 2 now. If I go to run that, I'll save it first. It's not problem 1 anymore, it's problem 2. But it should have the exact same result. See? So if I put 6.2, get the exact same result. Exact same result. Everything is happening the same, but what we've done is we've reorganized. All we've done is reorganize the program to make it into subroutines or functions. So we got these little functions, and they are really, really trivial. You won't write programs with functions that are so trivial like this, but they do let you see how a function is working. And just notice the 2-step part. We declare or define the function. I guess define is probably better because it's DEF, like define. And then later we call it. And of course, the name has to be spelled exactly the same. We see when we define the function, at that point, we indicate how many parameters are going to be passed. It could be 0, or it could be 1, or it could be more. In this case, there's 1. And then when we call it, we have to also pass one parameter. The other thing that we indicate in the definition is if there's a return value. If there is a return value, then when we call that function, we should call it, and we should set a variable to collect that return value, or we should print it or something. Anyways, and so that is working. That's problems 1 and 2. Is that okay? Anybody needs any more description of that? Because if not, we'll go right on to problems 3 and 4. So you guys good with this? It's fun, yeah? All right, so 2-step process. You got it, right? Define the function. That happens before the main. Then in the main, we call the function. Now, the other thing that we got going here that's worth reminding again is we've got this library called math, which has its own functions. And so, for example, the math functions that we were using power, which returns a value, doesn't it? Which is a number, which is then multiplied by another number here to give a result. But it takes 2 input parameters. Got another math function, which is pi, which doesn't, that's a weird one, isn't it? Because it doesn't even have brackets, but it returns a number, and it returns a very specific number. Okay, continue. Problems 3 and 4, yes? Yes? All right, let's go. Okay, so let's look at problems 3 and 4. It says add square perimeter and square area and compute the perimeter of a square. So, okay, it's kind of the same. We're just adding to it. Okay, so we need to add two more functions, which is, let's see, square perimeter. We're going to have a function called square perimeter. And what it's going to take is what? It's going to take a variable called side. I'll just call it S for short. And it's going to return a perimeter. So I'll make another P here. We already got a P in one of those other ones, but these are all local variables. This P is different than that P because they're local variables, okay? So I got a square perimeter. The other one was the area. Square area. Define square area. And that one, it's also going to take in a side. So I'm going to have so I'm going to calculate an area. These ones, so I'm going to calculate an area. I'm going to calculate a perimeter. You know what a perimeter of a square is? Perimeter is the distance around the edge. With a square, all the sides are the same length. There's 4 sides, all the same length. So the distance around is going to be 4 times the side. Where S is a side, and I don't know why I got caps lock. That's pretty simple, right? And the area is going to be side times side, right? Side squared. So you could do that with a math. We've got a math library, so why not? We're showing how we use math. So library, so let's do that. So in this case, the area is going to be equal to the math power X and Y, where X is the side and Y is 2. So that's going to be the square. There's our functions. They're too easy. So what we need to do is we need to add a thing that gets the length of the side of the square. So blah, blah, enter the side of the square. So we need now is that the side of the square? That's also a float. So basically it's going to be the same as this, right? I'm just going to take that and copy the whole thing and put it down here. And then I'm just going to edit it. And instead of radius, I'm going to have side. Side takes the value of enter the side of the square. And so you won't be able to see this unless I make it a bit smaller, I guess. So 16, let's go for 14. I don't know if you'll even be able to see that. Okay, so just like we did with the circle, we had to do these 2 calculations, right? So we have to do those 2 calculations here too. And so it's going to be, you know what I should have here is we got 2 different perimeters. So I'm going to make this a circle perimeter. Right. And I'm going to make this a circle area. Oh, you know what? Not circle perimeter, because that's the same name as our function. So I'll just make it shorter. I'm going to have C perimeter and I'm going to have C area. Now just make sure I print those right. So this is C perimeter and this is C area. So that I can have the square perimeter. So square perimeter is going to take the value of this function. When we pass the side to it. So the global variable for the side is side. So that'll work. And then the other thing that we need is the square area. And square area is going to take its value from this function. And we have to pass the global variable to it. And so that's got our, we need to now do the prints that go with it, which is these, the perimeter of the square is and the area of the square. So sorry about this taking a little while. Copy that. It's kind of using up a lot of space on this, aren't we? So this one is going to be a print. Print the perimeter of this. Oh, come on, go away. It's annoying. So I've copied this. The perimeter of the square is, and that's going to be the square perimeter, which, there it is. That's the perimeter. And then the area of the perimeter. Sorry, the area of the square. Anyways, I don't have to remember it's, oops. It's right there, isn't it? The area of the square. Copy that. Oops. The area of the square is. And it's this S area. And that's it, I think. Yeah, that gets us through all of that. So I'm going to take out some of these spaces. It'll make it maybe, I hope it doesn't make it too hard to read, but it was taking up all the space. So that should work. The program starts here. It asks you for the radius, then it calculates the perimeter and the area and prints them both out. Then it asks you for the side, then it calculates the perimeter and the area, then it prints them both out. Let's run that. Area radius of the circle, 6.2, and the radius of the square, 6.2. And if we've done it right, we got the same numbers, and we do. Our numbers are exactly the same. So that means our code is doing the same thing, we think. Okay. So what did we do? We added two more functions. Same idea. Define the function, then call the function, right? So we defined the square perimeter up there. We calculate the square perimeter here, passing a variable to it, which we got from the user. And we defined the square area there, and we calculated it here. Then we just printed out these variables. Yeah. You know, if you wanted to be really lazy, I could show you some lazy trick, right? What you could do instead of doing these statements here is you could just take this square perimeter and put it in the print statement here where the string is. That would work. That would work. Absolutely, it would work. And likewise here. So we could get rid of these statements here. It's 1, 2, 3. Should we do that? Should we do it the lazy man's way? You like the lazy man's way? So you got less typing? All right, let's do it. So what I'm going to do then is I'm going to take this. I'm going to copy it. Actually, I'm going to cut it. And I'm going to put it here for printing. So basically what I'm going to do is inside the string, inside the print statement, I'm going to call the function. the function is being called inside the print statement. I can do that with this one too. I'm gonna cut this, and that means we have less variables too. So yeah, why not? Why not? Let's be lazy. It's good to be lazy when you're computing, because then you have shorter programs and you have less errors. There we go. Okay, so blah, blah, blah. So I'm gonna do the same here. This one here for the square perimeter of the side. I cut that and then put that in there. And so I don't need this. Actually, the real reason why I'm doing this is because I just didn't have enough room on the page, right? And I'm going to take that from there, and I'm going to put it here. And so I don't need this variable. So we got rid of 4 variables, and we got rid of 4 lines of code. And we're doing all of our calculations actually at the same time as we're doing our print. That's fine. This is the function call. The value that's going to be returned from here is a number, and we're going to print it. How cool is that? All right, let's do it. Oh, well, let's do it so we can see it. So 6.2. Oh, we did something wrong. We got this thing here. Well, I was supposed to just copy that bit, but I got the C area bit too. Why did I do that? Let's try again. You know, haste makes waste, right? So 6.2, and I think those are the same numbers we had before. 6.2, I think those are the same numbers, and so it seems to work. And we got less lines of code, as long as you understand, right? Now, the other thing that I hope you learned by what I just did in the last 2 minutes is it's quite possible to have two ways of doing a program that are both correct. There's no one way of doing it, you know, and I write the same program 30 minutes apart and it'll be different, right? Because it's how you're thinking. It's kind of a creative process. I wish so you'll be thinking, oh, well, we're supposed to be engineers, right? And so engineers have standards, so they should do things all the time, the same way every time. Okay, yeah, good luck with that. Yeah, maybe. All right. Last one, modify the program so it indicates the end of the shape, the largest perimeter and the largest diameter. So we got 2 perimeters here, right? Oh, maybe we shouldn't have done that thing. Because now we have to measure those perimeters. Okay, we can call the functions again. But I mean, if we would have kept them in the variable, that would have worked all right. So anyway, so we're going to see, what does it do? It takes the largest perimeter and the largest area. So we do have to, so we have 2 choices now. We can go back and put those variables in there, or we can do the functions again. Which way do you like it? I don't know. Let's just do the functions again. What the heck? So we're going to have an if statement. Then we're going to say, all right, so which one has the biggest perimeter? So we're going to take this perimeter and we're going to take this perimeter and we'll see which one is biggest. So we're going to say, okay, so if this perimeter, yeah, copy that. If that perimeter is bigger than this perimeter, maybe this way will make sense to you, I hope. So we're checking out the perimeters, right? If the perimeter of the circle is bigger than the perimeter of the square, then we're going to say something about that, right? So what does it say? The perimeter of square, so we're going to say which one is bigger. The perimeter of circle. So if it is bigger, then we're going to say that it's bigger. And so that's this thing here. We say which one is bigger. Wow. I'm saying wow because that's a lot to fit on one page. That's all one line, right? So I'm just going to take half of it. take that. So actually, that's going to be in the else. This is what happens if the square is bigger. So if the square is bigger, that's the else, right? If this is false, if the circle is smaller than the square, then the square is big. Then we're going to say this thing about the square is bigger. And here we need to replace this with a value, which is a variable, which is the side. Because that's a, and then we'll print the other thing. I don't think we need to put them on the same line. We could put them on the same line. Do you want to put them on the same line? Then you just do this thing here. And equals that kind of thing. All right, so the next thing is there's two lines to that. That's this thing here, right? Let's do that. So then the perimeter of the circle of radius, and here we have to put in the radius. So that's what happens if it's not. So what happens if it is? We have two other prints. It doesn't even have them here, is it? The circle. So I have to make them up. Oh, it's in this other sample run, right? The perimeter of the circle is bigger. So I can take that. So if the circle is bigger, then I use this one. And so that's going to be here. And here, gonna have to have the oh, goodness gracious. And this was the radius, right? So I called it radius. And we got one more print to go, which kind of looks like that other one. We'll do this M thing again. This. Hard keeping track of it all, right? And so this has to be side. All right, so that's okay like that, but now we have to do the area. The area kind of works the same. Can you still see this? Do I have to make it smaller? Maybe. You're going to see it all at once. I don't know if you can still see it at 13. Can you see that? Make it whole? Make it big. You like it big? Okay. Back to big. So back to 16. That's big, but you won't be able to see it all at once. So the problem with that is you can't see it. Oh, the problem. How do I even get down there? I can't work on it. What do you want me to do? Oh yeah, then I can work on it. Yeah, all right, so now we're going to have another if else, and this time we're going to do it with the area. It'll be kind of very similar. So if the area, so we calculated the area here. Now we're going to see if the area of the circle. So we looked at the perimeter. Now we're looking at the area. So if the area of the circle is bigger than the area of the square. This. So that's what we're doing there. Then what we're going to do is, it's kind of like this, right? So if the area, I'm gonna copy this stuff. I hope you guys don't mind me copying it. Hey, you know, we like to save time, right? So I'm going to copy it and I'm going to edit it. I'm going to copy and edit all of this. Is that okay? So just copy and you'll see how I'm going to edit it. Everywhere where it says perimeter, I'm going to change it to say area, just like that. So circle area, circle area. So here it says perimeter, so I got to change that for area. And it's still going to be radius. There's not much to change, right? And so here we're going to say area. And here we're going to say area. And here we're going to say area. Because, you know, who likes typing? So we got that. I think that's good. Let's just double check. So at the first if else is working with perimeters, and we look in the condition, and that's all about perimeters. The print is all about perimeters, and it uses radius inside. That's fine. And then the next if else is working with areas, and everything in there is areas, no perimeters to be seen. Then we're still working with. I think this will work. So let's try. Okay, so the area of the circle is 6.2, and the area of the square, 6.2. And it says the perimeter of the circle, radius 6.2, is larger than the perimeter of the square. We should have said what the radius was, right? The area. Perimeter, did we not print the perimeter? We didn't, did we? Let's look at the, is it, you know what, if it's the same as here, yeah, it's fine. Perimeter circle of radius 10 is larger than perimeter. Yeah, okay, so let's see if we're correct. The perimeter of circle, the perimeter is 38, is larger than the square, which is 24. That's right. Okay, and then the area of the circle is, where's the area of circle? Area of circle is 120, and the area of the square is 38. So that's right. It's working perfectly. All right, as far as I can see. Do another sample run with 10 and 10. And then that's a lot of code, isn't it? So run it with 10 and 10. Now I mean that, I have written this program again. This is the second time I've done it today. I didn't do it this way last time. This is a little different. So what I mean by that is, if I see all of the ones that come in from you are the same, then you just copied, right? I know it's the first time you've seen this, so probably people are going to copy. Okay, so 10 and 10. And all right, so the perimeter of the circle is 62. The perimeter of the square is 40. So it should say the perimeter of the circle is bigger. Yes, it is. And then the area of the circle is 300. And the area of the square is 100. So the circle is bigger. So it got the circle bigger on both of them. That's awesome. I think that's working nice. Okay, so there's the whole code. You guys see the stuff at the top. What happens in this program is we had four functions. We called those functions, actually those four functions, we called them in print statements, because why not? And we also called them as part of our if statements. We use them in the condition. So I like doing that. And as I said, this is different than the way I did it this morning. I think it was this morning. No, this is the first class I've had today. Must have been yesterday I did it. It's different than the last time I did it because last time I did it, I didn't do the function inside the print and I didn't do the function inside the if statement. But you can. I wanted to show you can. I think that's a nicer way of coding because you have less code. Any questions? Okay, so you've got that lab to hand in and you've got an assignment. Do you think you can do the assignment on your own?
No.
Huh?
No.
You're supposed to. So I guess I'm saying good luck with the assignment. We can have a quick look at it. Any questions on any of the code? Is there anything there that you didn't, that you're looking at and saying, what does that do that I could explain to you? All of it you can look at. I hope I made it simple enough so you can see what it does, right? Yeah, and you got the general idea, which is you define the function first, and then in some other place, in this case, it's the main program, but you can actually call a function from another function. So well, that's what we're doing here. I mean, print is a function. Inside the print statement, we're calling here at the end, right? Inside the print function, are we not? Yeah, here. Inside the print function, we're calling these other functions to do a calculation with. Inside the print function, as part of the condition, we're calling two functions. Two functions called together. Why? Because each function returns a number, and so we're comparing the numbers that come out of those functions. Too much fun having. Okay, you had enough look at this. We could look at assignment 6. I don't think we'll have time to go through it all, but we could look at it and just see if it's really that hard. Is it sort of possible that you can do it? Loops and functions. All right, so inputting valid. This is kind of like what we did in the tutorial, right? This stuff here is very much like the tutorial. In the tutorial 6, please look at tutorial 6 to help you with this, because it asks you for a valid name. So here, the name must be alpha. Is alpha. We did that in the tutorial. So have a look at the tutorial on how to do this. Then we're calculating the average. That's stuff from last semester, from a couple weeks ago. Yeah, more average. Average is pretty easy. All right, with average, I hope you should memorize average, right? At the start of the program, count equals 0, total equals 0, right? While count is less than however many you're going to do. Then what do? You add, you get the variable, get number, add number to the total, add 1 to the count. Then after the loop, you take the total and divide it by the count. That's average. You should have it memorized. And so you're doing average here. What's the tricky bits there? I don't see any. It looks like an input of an integer. So you got a loop that's going to be a counter, and the counter is how many courses. So we did this before too. Actually, all of this is stuff you've done before, but maybe on a previous thing. Yeah. So we asked the user how many times we want to do the loop. So we get the number of times, and then the number of times is going to be the control on the loop. Done all that before. There's nothing there that you haven't done before. So I know, I don't think, well, what, do you want me to go through that? No, you can do it, right? Sorry? The assignment, sorry, how you were saying something? Make the assignment next week, sure. And if you get stuck, I can show you later. Okay, so talking about showing, we got a video going, and so I'm going to stop that.